All right, hello everyone. Today we're just adding a little bit of layer, a little extra practice to what we were doing last time with confidence intervals for a proportion. So again, just to remind you, this first formula is the standard error. It's just like how we were calculating standard deviation before, but in this context, we do not know what the parameter is. So we are building that little cushion around our statistic. So we're saying here, statistic times its complement over the sample size and then square root. That's our standard error. Okay, our margin of error, all we're doing is taking the critical value, multiplying by the standard error. Okay, so it opens that window essentially larger or smaller based on the confidence level. Okay, and then when we make our true confidence interval, we're saying, okay, well, here is our statistic that we have obtained. Here is the critical value. Again, that is all contingent on the confidence level that we set. And then here is the standard error. And then all together, that critical value times the standard error is the margin of error. I'll just write MOE. So we've seen that before, that it's always our statistic with the margin of error attached. Now we're just being more technical in how we calculate the margin of error. All right, so we have one big example that's going to carry us through. So many polling organizations track public's approval of the president, which varies from month to month. For several months after his inauguration, Barack Obama's approval rating stood at well over 60%, but it fell lower as time passed. In April 2014, with the midterm elections approaching, a Wall Street poll interviewed a random sample of 1,000 adults nationwide by randomly dialing both standard landline and cell phone numbers. Of those who participated, 440 people, 44%, said that they approved of the job that President Obama was doing. Okay, so we know it's a Wall Street poll. We're told it's a random sample. We got 1,000 individuals. That's our N. So we know that we have 1,000 individuals who are being polled. We know that our statistic is the 0.44, the 44% who are giving approval, and then the complement would be 0.56. Okay, so check if the conditions for calculating a confidence interval for a proportion are satisfied. So first, do we have randomization? Well, we trust the Wall Street poll. We trust them. Right? Anything in a newspaper, it's got to be random. Okay, how about independence? Okay, do we have independence? Do we assume that one outcome does not impact another? Yeah, I can assume that. Check. Okay, 10%. All right, we got millions and millions and millions of bodies in the U.S. So if we're only asking 1,000 of them, we are definitely below 10% of the entire population. And then, but are we big enough? Do we have at least 10 successes, at least 10 failures? So I'm checking my success and failure criteria. So N times P hat, gotta be greater than or equal to 10. N times Q hat also has to be greater than or equal to 10. So if I take my 1,000 people, multiply by 0.44, yep, got 440 who approve of Obama at this point in time. And then 1,000 times 0.56, I got 560 who do not. So excellent, my conditions are satisfied. Okay, so then I move on to the next step. So find a 95% confidence interval for the proportion of all U.S. adults who approve of President Obama's job performance during this time period. So I'm going to need to first find my critical value. Find that Z star, Z asterisk, critical value. Okay, so I'm picturing that middle 95%, right? This is what I'm visualizing. There's my middle 95%. Leaves me 5% in either tail, split it 2 ways. So I have 2.5 and 2.5%. Right? Those are the Z-scores that I'm trying to find. And then when I express it as a critical value, I express it as the positive. So here I'm going to do inverse norm, 0.02501. It's going to pump out a Z-score of negative 1.96. So my critical value will be 1.96. Okay, so here again, this would be the negative 1.96. This would be the positive 1.96. I'm taking it just as the positive right here. Okay, and then my confidence interval, let me remind you here as well, even though the formula is at the top of the page. So our confidence interval is the statistic plus or minus the critical value, that's the multiplier on the standard error. So square root p hat times q hat divided by n, just like that. So that's my confidence interval. And I know that this part together is my margin of error. So my statistic with that margin of error attached. Okay, so my statistic here is that 44%. So I'm just going to write it as a decimal, 0.44. My critical value, 1.96. And then what I'm plugging in here. So square root 0.44 times 0.56 divided by 1,000. Okay, so again, let me just show you how I crunch that. I usually do it in stages. So 0.44 times 0.56. Divide that by 1,000. Take the square root. And then multiply by the critical value, 1.96. So I'm getting 0.44 plus or minus 0.0308. Just taking it to 4 spots. So again, I can leave it like that. That is my statistic with the margin of error attached. I could also just do the calculation. So do 0.44 minus 0.0308 and then also add it. And that would build me from 0.4092 to 0.4708. Or again, write it as a percent. You got some options for how you want to write it. All 3 of these are saying the same thing. So it really doesn't matter to me. They're all telling me what that window is going to be. Okay, so write and interpret a confidence statement. So this should be a C. I'm just going to make that C. Okay, so according to the poll, we're always stating our source. So according to the poll, right, this is what we know. We know that 44% of those U.S. adults that were sampled approve of Obama. Right? We know it's at the snapshot of time. So at this moment in time, he has a 44% approval rate. Okay, and then we're saying this is how confident we are. So we are 95% confident the true parameter or the truth about the population, right? I often express it both ways. So the true parameter is within plus or minus 3.08% of this result. Okay, I could also build that window and say that it's between 40.92% to 47.08%, right? So we're trying to essentially predict his approval rating, right, at this period in time. Okay, and then again, of course, what does that actually mean? That's important to me that you guys know this, right? It's saying, okay, well, imagine that we took many random samples. So if we take many random samples. So remember that we are assuming that we're using the same methodology, right? So should be a good representative sample. So many random samples. 95% of the time, our true parameter should fall within this window. Right, and that window is the statistic with the margin of error attached. Okay, we know, well, that means 5% of the time. It does not. We can never guarantee our conclusion. Okay, so again, I'm just writing a confidence statement and I'm explaining what it's actually telling me, right? We know that the goal here is that we're trying to estimate, predict what Obama's true approval rating is. We're basing it off of a statistic with this little window attached, room for error. So we're saying, well, we would expect that in 95 of 100 samples, that the true parameter, his true approval rating, should fall within the statistic with the margin of error attached, right? But 5% of the time, it's not going to. We can never, ever guarantee a conclusion. We are constantly estimating, making predictions, but we can't say this with 100% certainty. All right, let's flip it. Let's look at the back, or the second sheet of paper. All right, so when we plan a study, we may want to choose a sample size that allows us to estimate a population proportion with a given margin of error. So here I'm just reminding you of the margin of error formula. So critical value times the standard error. Okay, the margin of error calculation includes the sample proportion, the statistic. Okay, unfortunately, we don't know the value of the statistic until after the study has been concluded, which means that we have to guess the value of p hat, the statistic, when we choose our sample size. So in the real world, there's really two ways to do it. We could use an educated guess for the statistic based on preliminary studies or past experience with similar studies. So again, we can use an educated guess, or we could use a statistic of 0.5. So if we use the statistic of 0.5 as our guess, what we're doing is we're making a conservative guess because it's going to give us the largest margin of error possible. So largest margin of error possible occurs when our statistic is at 0.5. So we're just giving ourselves an even bigger cushion of error to deal with when we don't know what our statistic is. Okay, and if that's what my intent is, I will tell you, use 0.5 as your statistic. Otherwise, I'm always giving you the statistic to build off of. Okay, so now lastly, how to calculate the sample size for a desired margin of error. So we have done this before, right? We did this before when we were using our basic quick method, and now we're just getting a little bit more complicated. So again, just reminding you of the formula and our context, we're looking at approval rating for Barack Obama in April 2014. So the statistic that we obtained was 44%. So let me just remind you of what we figured out from the other side, the other page. So our sample size is at 1,000. His approval rating is at 44%. I'm just going to write that as a decimal. So complement 0.56. Okay, the margin of error, again, we did already solve for it. So our margin of error was about plus or minus 3.08% or 0.0308 as a decimal. Either way is fine. And we were working with 95% confidence. So a little recap of what we did on the other side, right? One big example, and now we're doing the last bit of it. So what sample size is required to obtain a 95% confidence interval with a margin of error of at most 2%? Okay, so it's telling us margin of error at most, so at the very most, 2%. So margin of error has to be less than or equal to 0.02. So that's what we're told right from the beginning. So we need to first figure out, well, what's the critical value for 95% confidence? I know I'm going to need that, so I'm going to lay it out right here. So critical value for 95% confidence. We already solved for that too. That was about 1.96. Okay, so now margin of error less than or equal to 0.02. Okay, so my margin of error is going to be my critical value, so 1.96, multiplied by my standard error, so 0.44 times 0.56. But it's my sample size that I want to solve for, so I'm leaving that as n. And that has to be less than or equal to 0.02. So all I've done for my margin of error is I've plugged in everything I know. I know my critical value, right? It's a multiplier on my standard error. I know everything except for n, my sample size. That's what I'm trying to solve for. So now it's just an algebra problem, right? I want to get the n by itself. So I would start by dividing away the 1.96. Okay, so now my next step, I have the square root of 0.44 times 0.56 divided by n, and that's going to be less than or equal to, I'm just going to leave it as 0.02 over 1.96. So what I don't want to happen here is I just don't want to build off of rounded answers, so I'm not going to round until the very end. Okay, so now that I'm here, I want to unlock my square root. So I can unlock my square root by squaring each side. So now over here, I'm going to square both sides of my equation. So now my square root is gone. So now I have 0.44 times 0.56 over n is less than or equal to 0.02 over 1.96 as a quantity squared. Okay, so again, I'm not touching anything until the very end. So I'm just using my knowledge of algebra just to isolate the n. Okay, so now I want to get the n out of the denominator position, so I want to clear my fraction by multiplying each side of my equation by n. So now here, that part goes away. So I now have 0.44 times 0.56 is less than or equal to 0.02 over 1.96 squared times n. So now I need to divide away from each side that 0.02 over 1.96 squared, because I'm trying to get my n all by itself. Okay, so let me drag it up to here. Okay, and now I'm ready to type into my calculator. So this left-hand side right here, let me show you how I'm going to type it in. So my numerator is 0.44 times 0.56. I have that in parentheses. I'm going to divide that by my denominator, 0.02 divided by 1.96, and that quantity is squared. So here I'm going to get now 2,366.4256 is less than or equal to n. Okay, I always like my variable on the other side, so n has to be greater than or equal to 2,366.4256. Okay, so now we're talking about what sample size would we need to have a margin of error of at most 2%. So what I need to do now is I need to round to the nearest integer that makes this statement true. So it's not an equal to sign here, it's a greater than or equal to sign. So let me just write what I said. So round to the nearest integer that makes the statement true. Okay, so if I tried 2,366, is 2,366 greater than or equal to 2,366.4256? Well, no. So I have to round up. I have to round up no matter what this decimal is right here. Even if it was 0.01 right here, I'd have to round up to 2,367. So I'd have to have a sample size at the very least of 2,367. Okay, and that would create a margin of error of at most 2%. So let me just say that one more time. So my sample size that would create that 2% would be 2,367. Okay, and then lastly, E. How big of a sample would be required to cut the margin of error in half? So here I'm just going to revisit that quick method that we did before. So with my quick method, let me just remind you, quick method, because the concept really does carry over. So the quick method is saying, okay, let's imagine that my sample size is, say, 400, and that would be a margin of error of plus or minus 0.05, and I'm just going to write it as a fraction, so 1/20. So I'm just imagining a sample that's 400 originally with a margin of error of 0.05 or 1/20. So remember that here 1 over the square root of n is equal to 1/20. So I'm just looking at it like that first. So my margin of error is 1/20. But I want to cut it in half. So I want it to be 1/2 of its original value. Okay, so I put the 1/2 right in there. So now if I'm trying to solve for n, I can visualize this as a proportion and cross multiply. So I have now the square root of n here is equal to 2 times 20. And now when I solve by squaring the square root, like that, it's going to give me that n is 2 squared times 20 squared. So 4 times that original 400. So if I want to cut the original margin of error in half, make it half of its original size, then I have to quadruple my sample size. So here that 4, right, that's telling me, well, I had to multiply by 4 or quadruple. Okay, so if I'm looking at an original sample size, so in this problem, our original sample size was 1,000. We had polled 1,000 individuals when we were asking about Obama's approval rating. So if I'm taking that 1,000 and I wanted to cut the margin of error in half, well, then I got to multiply this by 4. I have to quadruple it, and my new sample size would be 4,000. Okay, I am all good for today. Hopefully the 2 days of confidence intervals helped it sink in a little bit better. I'm always optimistic. I hope you guys are having a wonderful rest of your day.